Section 3 of the Lines and Triangles unit is going to start with a little bit of review of the different kinds of triangles. So first we're going to talk about a scalene triangle, which has no equal sides. You're going to see that with actual numbers being given to you, or you'll see that with three different kinds of hash marks. Scalene triangles will also have no equal angles, which is a neat property when we start talking about trying to tell what different triangles are. Isosceles triangles have two equal sides, and we're going to find out that they have two equal angles, and that is a key feature as we move forward. So again, you're either going to be given the specific numbers or you're going to be given these hash marks. What's cool is that opposite those equal sides are always the angles that are equal. An equilateral or equiangular triangle is exactly what it sounds like. It sounds like equal, lateral is side, or equiangular is angle. So we either have all three sides equal, or we have all three angles equal. And so those are just some ways that we can begin to distinguish different types of triangles. Another type of triangle that you're probably familiar with is a right triangle, and it always has one right angle. That's its defining feature. You can have a scalene right triangle, and you can have an isosceles right triangle. So we can begin to name triangles very specifically. So if these two angles were equal, this would be an isosceles right triangle. This, just by looking at it, is a scalene right triangle. And the more descriptive we can be about our shapes, the more likely that everyone will see the same picture that we want them to. So the Pythagorean theorem is a theorem, a formula that you're probably very aware of. Keynote always is that it only works for right triangles. So make sure if you're using the Pythagorean theorem that you do have a right triangle. So if we take our right triangle ABC, there's very specific naming for triangles. Opposite vertex A, that side is little a. Opposite vertex B is little b, and opposite C is little c. Again, we do this so that if I describe or give you sides or give you angles, everyone will get the same triangle. The Pythagorean theorem says if you take the two sides, square them and add them, you get the hypotenuse. And if you'd forgotten, the side opposite the right angle is the hypotenuse. The two that form the right angle are called the legs. So let's talk about classifying some. When I look at this picture in A, I have three different sides. I know nothing about the angles, so that is a scalene triangle. If I look down at B, I have three equal sides, and so this is an equilateral. C, two equal sides and a right angle. This is a right isosceles triangle. And our last example down here has three different hash marks, and so this is scalene. So a nice little review of our kinds of triangles. So let's do a quick review of a couple Pythagorean theorem examples. If I draw myself a picture and I have legs of 7 and 12, the hypotenuse is what I don't know, so we give it a letter. The Pythagorean theorem says if I take 7 squared plus 12 squared, it equals h squared. Do my squaring first because of my order of operation. Go ahead and add 49 plus 144 is 193. We undo squaring by taking the square root. And so h is the square root of 193, which is an okay answer. We'll talk about simplifying those later. Or you can go to your calculator, and that's approximately 13.9. We can also use the Pythagorean theorem to find missing sides. The side opposite the right angle is always the hypotenuse. So we're going to take x squared plus 8 squared, and that will always equal the hypotenuse. So again, we're going to follow order of operations. X squared plus 64 is equal to 196. Subtract 64 from both sides. Take the square root. X is the square root of 132, which is approximately 11.5 when you go to your calculator. So that covers our triangle review. Tune in to the next video as we start talking about some specific segments that occur in triangles.